of reducing rational expressions. And example 4 is 4y times 3 minus y times y plus 4 over y times y squared minus y minus 6. So the numerator is fully factored. We have 4y, we have y minus 3, and we have y plus 4 nice and factored. In the denominator, we have y factored, but y squared minus y minus 6 is a quadratic trinomial, which still needs to be factored. So we're going to factor the denominator, and in order to do that, we're going to make a chart. We're going to find numbers that multiply to give us negative 6, but add to give us, this is negative y, so the number we need is negative 1. So numbers that multiply to give negative 6, let's try negative 2 times 3, and now we're going to add negative 2 plus 3. I need one of the numbers to be negative because this is the negative number. The other number must be positive. So now negative 2 plus 3 is positive 1. I want a negative 1. So one thing I can do is switch the signs here, and we can say negative 3 times positive 2, and the negative 3 plus 2 is indeed negative 1. So these are the two numbers we're going to use to factor this polynomial. So the numerator stays the same. We're going to say 4y times y minus 3 times y plus 4 over y, and now we're going to factor. Now since y squared is the leading term, my leading term in one of my factors is just going to be a single y. And then I'm going to put the first number that I found, which was negative 3. So we're going to put minus 3, close parentheses. We're going to open another parentheses, and we're going to put the second y. Remember, this is y squared, so I need y times y to get y squared. And then the other number is positive 2, so we're going to put plus 2 and close parentheses. Now we're going to reduce. We're going to check the numerator and denominator to see if we have any common factors and use the inverse property of multiplication to reduce. Now notice here I have y and y nice and factored, so we can reduce that to just 1. Then I have y minus 3 and y minus 3. We can reduce those to just 1. So we have 1 times 1 times 4 times y plus 4 over y plus 2. So this is just 1 times everything, so it's not going to change anything. So we just write what's left over. We have 4 times y plus 4 over y plus 2, and I don't need the parentheses anymore because there's nothing around it. Oops, I erased it a little bit right there. And that is our reduced rational expression. Okay, let's move on to example 5. So example 5 is 5z times 3x squared minus 4xz times y minus 3 over 10x times 4z minus 3x times y squared minus 9. Okay, so it looks like we need to factor both in the numerator and in the denominator. The 5z and the 3 and the y minus 3 are okay. We don't need to factor those. But the 3x squared minus 4xz, I have a common factor of x, so we need to factor the x out. In the denominator, the 10x is okay, the 4z minus 3x is okay, but the y squared minus 9 is a quadratic binomial, so we need to factor that. Okay, so let's factor the numerator first. So in the numerator, we're going to have 5z, and then we need to factor the x here. So we're going to factor out x, open parentheses, 3x, because we went down by 1x, we took out the x, so x squared becomes x, minus 4, we took out the x, so no more x, and we're just going to be left with z. Close parentheses, times y minus 3, all over 10x times, now before I write 4z minus 3x, notice this is 3x minus 4z. It's the reverse. So I'm going to write this backwards. I'm going to write negative 3x plus 4z because this is going to reduce to a negative 1. Okay. And now we're going to factor y squared minus 9. So we're going to do a chart. We want numbers that multiply to give us -9. There is no middle term here, so my middle term is 0. Okay, we don't have a trinomial here. We don't have 3 terms. So that middle term where the y would normally be is going to be 0. So the two numbers that multiply to give -9 but add to give 0 are -3 times +3. -3 plus 3 is indeed 0. So when we factor y squared minus 9, we're going to have 2 factors. So let's extend this. The first term is going to be y for both of them because this is a y squared. And then the second part is going to be my -3 and my +3. So -3 goes here and +3 goes here. Okay, so now I want to factor out the negative from the 3x. So we're going to rewrite all of this. We're going to say 5, and then we're going to reverse the x and the z just so we can have it in alphabetical order. So xz times 3x minus 4z times y minus 3 all over 10x, and we're going to take out the negative from here. So it's going to be in the front. It's going to be a -10x times, and now that's going to change to a +3x, and this +4z is going to change to a -4z. Close parentheses, times y minus 3 times y plus 3. And now we can reduce anything that's in common in the numerator and in the denominator. Now, 5 and 10, I can reduce those by 5. 5 reduced by 5 is 1. 10 reduced by 5 is 2. Okay, the x's are going to reduce to just 1. Z stays. 3x minus 4z and 3x minus 4z are both going to reduce to 1. Y minus 3 and y minus 3 is also going to reduce to 1. So what's left is 1 times z in the numerator over a -2 times y plus 3. Okay, now we're going to clean this up a little bit. We're going to clean this up as 1 times z is just z over -2 times y plus 3. Now, I don't like the negative being in the denominator, so we're going to move it. Let me just erase here a little bit. We're going to put the equals a little bit closer over here. We're going to move the negative to the front, okay? That way we know that this rational expression is just negative. That's what the negative means. It means the whole thing's negative. And that is our reduced rational expression. And that is all of our examples for this series. Please stay safe out there.